Hey YouTube, welcome back to another tutorial. In this one, I'm going to be teaching you Leetcode problem 13, Roman to integer. So let me go ahead and read this problem and then I'm just going to teach you how to solve it. So Roman numerals are represented by 7 different symbols, I, V, X, L, C, D, and M. And here we have a little map showing us the conversion between each symbol and its decimal value. So we can see here I is equal to 1, V is equal to 5, X is equal to 10, so on and so forth. So, for example, 2 is written as II in Roman numeral, just 2 ones added together. 12 is written as XII, which is simply X plus II. The number 27 is written as XXVII, which is simply XX plus V plus II. Roman numerals are usually written largest to smallest from left to right. However, the numeral 4 is not III. Instead, the number 4 is written as IV. Because the 1 is before the 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. There are 6 different instances where subtraction is used. I can be placed before V and X to make 4 and 9. X can be placed before L and C to make 40 and 90. C can be placed before D and M to make 400 and 900, given a Roman numeral converted to an integer. So let's look at some examples. If the input string is III, the output will be 3. Explanation III is equal to 3. As we can recall, each I is equal to 1, so we add them all together to give you 3. Another example, S is equal to LVIII, which is 58 as our output because L is equal to 50, V is equal to 5, and III is equal to 3. And for our third example, given input S equals MCM XCIV, the output is 1994 because M is equal to 1000, CM is equal to 900, XC is equal to 90, and IV is equal to 4. Now our constraints is that S.length is greater than or equal to 1 or less than or equal to 15, and S contains only the characters I, V, X, L, C, D, and M. So we're not going to get any Roman numerals past that, and it is guaranteed that S is a valid Roman numeral in the range 1 to 3999. So let's get into how we're going to solve this problem. So the first thing we can tackle right away is just converting each respective symbol to its value. And how would we do that? Well, we could simply loop through it all. We could have a case for each letter or Roman numeral, and then we can convert it and then add it to the value. Sounds good, right? Well, that would work, but we also have to keep in mind there is a bit of subtraction that we have to do. So while you could get away with making a case for every single Roman numeral and then perhaps having a couple if statements to check if the character before is less than the current character, then we would subtract it. That is valid. However, in code, we always want to have dry programming. And what does dry stand for? It stands for do not repeat yourself. So the problem with using cases is that for every case, we would have similar code, or actually the same code, to check if the Roman numeral before it is less, and then we would subtract that value. It doesn't make sense to repeat that code over and over again. So instead of using cases, what we're going to do is we're going to put all these values into a hash map. So let's define a new map. So I'll say let Roman equals new map. And then what I'll do is I'll add a key for each Roman numeral, which translates to its respective integer value. So for the first one, I'd say Roman.set I as 1. And now I'm going to set the rest. Alright, so now I set every Roman value to map to its respective integer key. Now you might be wondering, why did I set up my map like this when I simply could have just said something like let Roman equals curly braces, and then inside those curly braces I could have set I to 1. I could have set V to 5, and so on and so forth. Well, that actually isn't the proper way to use a hash map in JavaScript. That'll fly for Leetcode and it'll be a lot faster, but it's good practice to use hash maps this way because that's how you're going to see it in theory. That's the correct way to use it in the real world, you can say. And the reason being, using an object does provide the same functionality. However, it does come with some default keys That could later mess with our code if we were using this in a real world application, and we don't want any of those. Anyways, now that we have our map set up, the next thing we're going to do is to set up a result. And the reason we're setting a result is that once we're looping through this string, we're going to take each character in the string, look it up on our hash map, and add it to the result. And if the character that comes before is less, for example right here, if an I came before a V, we would subtract that to make 4. So we're also going to subtract those respective values from the result. And that's going to give us the final result. Now I'm going to set up a for loop. Now, instead of looping through each individual character from start to finish, we're actually going to go in reverse. And that's going to make it a lot easier to do the subtraction, because we're going to check if the number we ran into is smaller than the one that's to the right of it. And the reason we're doing that is because we're going to have to subtract that value. And it's a lot easier to subtract that value if we're going in reverse. And remember, it doesn't matter which order you add something, but you already know that. So we're just going to add the results as we go. And then we're going to subtract each value instead of add it anytime before that value that came in front of it is less than the one that came before. So I'm going to set I to equal string, the string.length -1. And the reason we're doing -1 is because strings are 0 indexed. So if we point to the s.length, we're actually pointing at something that's undefined. Now we'll say while I is greater than or equal to 0, we're going to subtract I. Now I'll create a temp variable. And I'll say let temp equals to roman.get s of I. Now this temp is going to be the value we either add or subtract to the result. So now all we need to do is check whether we add this or subtract this. And how do we check that? All we have to do is we have to check if the number that's to the right of it is greater or less than that value. If it's greater, we subtract it. If it's less, we add it. So I'll say if temp is less than roman.get s of I plus 1. Because we're looking to the value that's to the right of it. But we also have to make sure that this isn't the first value we looked at, because the value to the right of it is going to be undefined. So we have to check for that undefined. So I'll say if I is not equal to s.length -1. If both those conditions are true, then we can continue our loop. And there should be another equals here. And in this case, we're checking if temp is less than roman.get. So if the temporary value is less than the one to the right, what do? We subtract. So I'll say result minus equals temp. Otherwise, we're simply going to add the result. And once we're done with this loop, we're going to return the result. Now let's submit this code and see if it worked. And you'll see we got the correct solution. Now let's discuss the time and space complexity of this. The time complexity is going to be O of n because we're simply looping through once. We're iterating through the length of the array. So the length of the arrays is going to be our time complexity, which is O of n. And our space complexity is going to be O of 1 because we're only setting these values once. So that's going to give us a constant time, which is O of 1. Anyways, guys, like and subscribe if you learned something, although you don't have to, and I'll catch you in the next one.